Betelgeuse, a crimson-hued red supergiant located in the constellation Orion, has captivated astronomers and stargazers for generations due to its immense size and brilliant luminosity. If it were placed at the center of our solar system, its outer edges would reach as far as Jupiter's orbit, a striking indication of its colossal proportions. Despite being roughly 642 light-years away, its sheer magnitude makes it one of the brightest stars visible to the naked eye. In recent years, however, Betelgeuse has exhibited unusual fluctuations in brightness, dimming and brightening in ways that have baffled scientists. Many believe these signs suggest the star is nearing the end of its life. Esteemed physicist Brian Cox recently announced a groundbreaking prediction. Betelgeuse is on the verge of a cataclysmic explosion, possibly within the next 2 weeks. This upcoming event, a Type II supernova, will mark the dramatic end of Betelgeuse's life. As a red supergiant, it ranks among the most massive stars in the cosmos, and its explosive death will offer a rare opportunity to study one of the universe's most powerful and fascinating phenomena. When a massive star like Betelgeuse reaches the end of its life, its core collapses under the force of gravity, releasing a burst of neutrinos and radiation. This triggers a violent shock wave that tears the star apart in a brilliant explosion. A supernova of this scale will emit more energy in mere seconds than our sun will produce over its entire lifetime. If Betelgeuse does explode, it could shine so brightly that it may outshine the moon and be visible from Earth with the naked eye, possibly even during daylight, for weeks or even months. Thankfully, Betelgeuse's distance from Earth ensures that this stunning display will pose no threat to life on our planet. While a supernova occurring closer could be devastating, the 642 light-year gap guarantees we'll enjoy the spectacle safely from afar. This event is expected to revolutionize our understanding of stellar death, supernova mechanics, and cosmic chemistry. Scientists around the globe are preparing to monitor the explosion with an array of powerful instruments, including the Hubble Space Telescope and James Webb Space Telescope, JWST, to capture data from the earliest possible moment. One particularly exciting aspect of the supernova will be the detection of neutrinos, ghost-like subatomic particles that can pass through nearly all matter unhindered. These elusive particles are likely to reach Earth before the light of the explosion, offering scientists a rare head start in studying the event. Facilities like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are on high alert to capture this early neutrino wave. Additionally, Betelgeuse's explosion will offer first-hand insights into how heavy elements, such as iron, gold, silver, and uranium, are created and dispersed throughout space. These elements are the building blocks of planets and life as we know it. Observing this process in real time could unlock new understandings of the universe's chemical evolution. Though the explosion won't be dangerous, it could still impact Earth's upper atmosphere and magnetic field, potentially resulting in enhanced auroral activity. Cosmic rays and charged particles released in the blast may cause spectacular displays of the northern and southern lights, visible at much lower latitudes than usual. In essence, the impending Betelgeuse supernova represents both an end and a beginning, the death of a stellar giant, and a once-in-a-lifetime chance to deepen humanity's knowledge of the universe. Although cosmic rays from Betelgeuse's explosion might momentarily disrupt satellite communications and certain technologies on Earth, these effects are expected to be minimal and short-lived. What makes this event truly exhilarating is its visibility. Unlike many astronomical phenomena, Betelgeuse's supernova will be observable by everyone on Earth, not just professional astronomers with high-powered equipment. For weeks or even months, it is predicted to outshine every star in the night sky and might even be visible during daylight hours. This rare spectacle is set to captivate both scientists and the general public, sparking renewed curiosity about astronomy and the universe. Astronomers have speculated for years about Betelgeuse's inevitable end, but recent remarks by physicist Brian Cox have brought a newfound urgency to the discussion. In response, observatories across the globe are preparing to closely monitor every phase of the explosion. The data gathered will be invaluable, offering insights that could reshape our understanding of stellar life cycles, core collapse supernovae, and the cosmic distribution of matter. Because Betelgeuse is relatively close to Earth in cosmic terms, its explosion presents a unique chance to study how energy from a supernova travels through space. Scientists will examine how its light and radiation interact with the interstellar medium, the gas and dust that fills the void between stars, to better measure cosmic distances and refine existing models of the universe's scale. Crucially, this supernova may also help unlock secrets about dark matter, the mysterious substance thought to make up approximately 85% of the universe's matter. Since dark matter doesn't emit or absorb light, it's incredibly hard to detect directly. However, by observing the behavior surrounding light and material after Betelgeuse explodes, researchers hope to uncover indirect evidence of its presence and influence on cosmic structures. The explosion will also enhance our understanding of stellar evolution, particularly how massive stars forge and disperse the heavy elements essential for life. Supernovae are the universe's primary method for distributing elements like carbon, oxygen, and iron, building blocks for stars, planets, and living organisms. By studying Betelgeuse, scientists can gain deeper insights into how these elements are created and scattered throughout space. Beyond science, the cultural and philosophical impact of Betelgeuse's demise is profound. For thousands of years, humans have gazed at the stars for meaning, inspiration, and guidance. The disappearance of such a prominent celestial body, long a fixture in the constellation Orion, will serve as a striking reminder of the universe's impermanence. Historically, celestial events like this have often been seen as omens or signs of transformation, and this one may evoke a mix of awe, reflection, and wonder. Modern technology means nearly anyone with a telescope or even a camera can participate in observing and documenting the event. This democratization of science allows people worldwide to share in a singular moment of cosmic history, each from their own vantage point. Enthusiasts and amateur astronomers are already preparing, united by the thrill of witnessing a star's final act. Ultimately, Betelgeuse's explosion will be more than a spectacle. It will mark a milestone in space exploration and astronomical discovery. The knowledge gained will shape how we study other stars and supernovae, which is essential as humanity sets its sights on deeper space missions. Understanding stellar life cycles and cosmic processes is vital as we explore beyond our solar system. Moreover, the event could reinvigorate the search for extraterrestrial life. Since supernovae spread life-enabling elements like carbon and oxygen across the universe, examining Betelgeuse's explosion might offer fresh clues about how these ingredients reach potentially habitable worlds. In this sense, the death of a star could bring us one step closer to answering one of humanity's greatest questions. Are we alone? The upcoming explosion of Betelgeuse is set to be one of the most momentous astronomical events of our time. This supernova will not only generate an extraordinary wealth of scientific data, but also deepen our understanding of the cosmos and mesmerize people around the globe. Although the end of Betelgeuse will mark the death of a massive star, it will simultaneously highlight the eternal cycle of creation and destruction that shapes our universe, a powerful reminder that from endings, new stars, planets, and possibly life can emerge. As the world looks to the night sky in anticipation of this spectacular event, scientists and stargazers alike prepare for a breathtaking cosmic display. One of the more speculative yet compelling aspects of Betelgeuse's imminent demise is the opportunity it presents to unravel some of the universe's greatest mysteries, namely dark matter and dark energy. These elusive forces are believed to make up the vast majority of the universe's mass and energy, yet they remain poorly understood. There's growing curiosity in the scientific community that supernovae, such as the one expected from Betelgeuse, might hold clues to these enigmas. These explosive events emit tremendous amount of energy and radiation, which could potentially interact with dark matter in observable ways. One leading theory posits that dark matter is composed of weakly interacting massive particles, WIMPs. If WIMPs exist, their reaction to the energy released by Betelgeuse's explosion might finally shed light on their nature. Such a discovery would be revolutionary, offering the first direct evidence of dark matter after decades of searching. Similarly, Betelgeuse's explosion might help scientists better understand dark energy, the mysterious force responsible for the accelerated expansion of a universe. By analyzing how light and energy from the supernova behave over time and distance, researchers may gather vital clues about how cosmic events influence the universe's growth and how they might tie into the properties of dark energy. These insights could fundamentally reshape modern cosmology and expand our knowledge of the very structure of space and time. Beyond these grand mysteries, the supernova offers an unprecedented opportunity to study the life cycle of massive stars, especially red supergiants like Betelgeuse, which are rare and pivotal to cosmic evolution. These stars are born from immense clouds of gas and dust that collapse under gravity, igniting nuclear fusion at their cores. As they run out of hydrogen fuel, they expand dramatically and shed mass through intense stellar winds, enriching the interstellar medium and setting the stage for new stars to form. When Betelgeuse goes supernova, it will offer a clear, real-time view of a massive star's final moments. Scientists will observe the aftermath closely, searching for formation of either a neutron star or a black hole, both of which would offer valuable insights into the physics of stellar death. The explosion itself will create a shock wave that sweeps through surrounding gas and dust, causing it to glow and revealing details about the elements produced during the event, such as iron, nickel, and other heavy metals. Studying the spectral fingerprints of these elements will help researchers understand their distribution and role in shaping future star systems and potentially habitable planets. Another thrilling possibility is the detection of gravitational waves generated by the core collapse. Observatories like LIGO and Virgo may pick up these ripples in space-time, which carry unique information about the violent dynamics of the supernova and the possible birth of a black hole. These gravitational signals could unlock new understanding about the internal mechanics of such cataclysmic cosmic events. Finally, Betelgeuse's supernova may act as a catalyst for advancing astronomical technology. The expected flood of data could challenge the limits of current instruments, prompting innovation in imaging systems, data processing methods, and real-time analytical tools. These technological leaps could benefit a broad spectrum of future research far beyond this single event. In short, Betelgeuse's final act promises not only to light up our skies, but also to illuminate some of the deepest questions in modern astrophysics. As we await this awe-inspiring moment, we stand on the edge of potential discovery, ready to learn, to marvel, and to witness the universe in action.